So this time we will learn about NumPy in Python. NumPy is the array implementation in Python. Since Python does not have its own array implementation, Python lists can do similar things, but lists are significantly slower than NumPy arrays, as NumPy arrays are specifically designed to store the data inside the array in a contiguous manner. So all the data inside the memory or the physical RAM is stored one after another. So whenever doing some operation, to find any particular data, it is very fast. Now NumPy is a Python module, so it is obviously partially written in Python, and to give it a nice performance boost, some of its parts are written in C or C++. So let's start with the basics. So once you have NumPy installed, which you can do using pip install NumPy in the command line, and I actually have this already installed, so it is saying requirement already satisfied, but in your case it will take some time and install NumPy. You can proceed to importing NumPy as np. So let's create our first NumPy array. So this is a scalar array or a zero dimension array. As you can see over here, np.array method I have used, and inside the method I have given this parameter. So if I print this, you can see that 16 has been printed. This is a scalar array, and this is how you define a scalar array. Now to define a one-dimensional array, you want to use a list or any iterable. So np.array, and inside that, instead of this single value, we are passing in a list with various numbers. And this is how we will create an one-dimensional array. So if I print this, also I'll print the type of this and I'll run it. You can see that the commas are not in the print message, because this is a NumPy array, and this is how NumPy arrays are represented. Now, if we check the type itself, this is not list anymore. This is of class numpy.nd array. So, numpy.nd array is the special kind of data structure or array implementation that NumPy does. Now, we can easily do indexing on this array like in a list. So, the third index, which is 3 over here, has been returned. Now basic slicing also works. So from the first index we'll go up to the fifth index, but everywhere else in Python, the fifth index will be excluded. So let's run this. It will be 1, 2, 3, and 4. Now we have to remember that the scalar array that we created before, one dimensional array, it does not have any depth, or in fact this is not iterable. So indexing and slicing is not allowed for the scalar array. Now this is how we can create a two-dimensional array. So we have a nested list. So the top level list has 4 elements, and inside each element there are 3 elements in the list. So if we run this, we can see that it has been printed nicely by NumPy itself. So this is a two-dimensional array. This is how you can represent a 4 cross 3 matrix actually. And the shape is 4 comma 3. So in the shape, the 0th index represents the top level, and the next index is representing the depth after that. So this is nested. So in the top level we have 4 elements, and inside that every element in the top level has 3 more elements. So if we have more nested arrays, this shape will be 4 comma 3 comma x comma y comma z, like that. Now in NumPy, we can actually check that where exactly the data lies inside our physical memory. So for that we can do array dot data. So this data property will return the actual memory address of that stored data. So if we print this, and I'll also add in the type of this. So as you can see that the array has been stored in this particular memory address, and this is of type memory view. Now as I mentioned that data inside NumPy are stored in a contiguous manner, we can actually check that if it is true or not using this contiguous property in the memory view. So contiguous is actually true. Now we got the starting address of the data, but we also need how many items are there to get the complete array. So for that we can do dot item size. If we done this, we can get the size is 8. Now to get the underlying data from the memory view, we can do dot object. This will actually return us the numpy array. So from that numpy array using dot data we got the memory view, and from the memory view using the dot object method we can get the data itself. So inside memory view we can actually change the data. So as you can see, we are doing a weird kind of indexing over here because we have written 2 comma 1. So this 2 first of this indexing will represent the indexing inside the top level. Then as we give comma and go to the next level, it will go inside the array. So in the top level, we'll go to the second index, which is over here 0, 1 2 7 8 9. So this element we are first picking up. Then after comma, we are going inside it. So from that, the first index we want to grab. So we should have 8 replaced by 99. So let's see the print. As you can see, instead of 8, it is 99 right now. So the get item method is what actually is being used to do this slicing in the NumPy array. So if we run this, we can see that we grabbed 99. So from 2, then we went to 1. Now we can actually return all of this data as a byte string. So using .2byte method. So if we do that, we can see that a really long byte array has been printed out and which holds our data actually. Now coming to the basic data types in NumPy array. So besides Python's own data type, NumPy actually uses its own definition for each data types. So I for integer, B for boolean, E for unsigned int, C for complex floats, F for float, and S for string. So this kind of data types you can find inside the NumPy array. Now to see any data type of the array, we can actually use .dtype method. So if I run this, I can see that all of this data or this NumPy array is filled up with int64 kind of data. So more things we can do is like we can index any data and we can get its type. So we can get that the zeroth element which is 1 over here, which is actually numpy dot int64. Now with indexing we can also do normal operations. So zeroth element plus first element, so 1 plus 2, since both are int64, we will just get the sum between 2 and 1, which is 3 over here. Now let's do something different which is not recommended. So let's create an array with mixed data types. So over here all the other elements are int 64, but the last element is a string. So let's try to print the data type, and as you can see this data type is this symbol. This symbol is very different from what we saw earlier, right? It is not int 64 anymore. So this is a character code that NumPy uses to identify its underlying data. So this symbol over here at the first, so this less than symbol signifies it is a little Indian format data. And then the U stands for Unicode and 21 stands for there are 21 characters. Now I will print the type of my array 0. So for the zeroth element previously we got it was int64, but if we run it now, we can see that numpy underscore string has been returned. So this one has been converted to string because the array that was needed to create and store all of this data had one string in it, and this actually forced to create the whole array as an array of strings. Now, if we just do the plus operation, unlike previous times, this is now string concatenation, not addition anymore. So, the string 1 plus the string 2 will return us the string 12. Yeah, so make sure you don't mix up data types unintentionally when working with NumPy arrays, or unexpected behaviors like this may happen. Now we can specify a specific data type to the array creation itself. By this, even there are no complex data types inside this list that I am passing in, all the data types will be forced to be represented as a complex number. So if I print this, as you can see all the data we passed in, so 0 has become 0 plus 0j, 1 has become 1 plus 1j, and so on. 6 has become 6 plus 0j. Like that, all the data type, since we forced it to be complex 128, it has all become a complex array. Now, like the previously shown mixed data type arrays, we had the string 6. We can also put any complex value inside any list and create a numpy array of that. Then, even if we don't declare this d type equals to num np.complex 128, it will still become the complex 128 data type. So if we run this, so as you can see, this array has been dubbed as complex 128 because of these complex values. Now moving on to copy, let's create a fresh array. Now I will do array.copy method. This will actually create a copy, so which is not actually linked to this array anymore. So this copy, if we modify this copy, this will not change the original array, or if we change an element in the original array, this will not affect the copy itself. So over here I am modifying the second index element and the copy array, and I am printing the original and the copy. So let's print this. As you can see that original is as it is, but the copy has 16 in it. Similarly, we can use view, which actually will get a reference to the existing array, not a copy of it. So if we recreate this array again, then we can do array.view method, and I will change any value inside the view only. So now we want to print the original and the view of array. So if we print this, we can see that the original array has also been modified from the view because the view is a reference only. So whatever changes we make in the view will get reflected in the original array also. So unlike copy, where the array and the copy of the array both will hold memory in the RAM, the view will hold only the memory required to save the reference, not the entire array. So if we have an array and we use the dot base method and print it, we can see that none has been printed. But if we have a view, then we do the base method, the base underline array that was used to create this view will be returned instead. So if we run this, we can see that the base array has been returned. But for the main array itself, the base is none because it is the base only. Now let's create a 2D array, and I can do dot shape method to actually get the shape of this data. So over here we have 4 comma 3. Also we can force any shape to an array. So originally we created a 2D array, So the shape was 4 comma 3, and now we are specifying that the number of dimensions should be 5. So by creating this array, let's see what happens. If I print this, it will give me an array which has this weird kind of shape. So 1 comma 1 comma 1 comma 4 comma 3. If you notice over here, this 4 comma 3 has been appended in the last. So it has to create a 5 dimensional array. So it has created that, and in the maximum possible depth in that array, it has initiated our specified data that we passed into this 5D array. Now we can do reshaping of the array. So to do reshape, you have to make sure that the shape of the array, which was 4 comma 3 over here, so 4 into 3 if we do, it will become 12, and your shape whatever it is, so you have to multiply all of them, and it will become 3 into 2 into 2, so 12 again. So this shape and whatever you want to reshape to should have exactly that many elements in it. So if we have an array with 12 elements, we can only reshape to another array which will also have 12 elements, but we cannot reshape into another array which has 13, 14, or any other different number of elements. So if I print this, and I'll also print the shape of this, I can see that the array has been modified to fit this shape, and the resultant shape is 3 comma 2 comma 2 as we specified. Now iterating over NumPy array, so we can simply use a for loop and we can get the data itself. So if I run this, as you can see that the data has been taken from the my array, and we can actually iterate over there. So over here we have a two-dimensional array, and we actually want to iterate over the scalars of this array. So by scalars I mean the maximum possible depth. So all of those elements we want to iterate over. So to do that for a two-dimensional array, we have to write a nested for loop. So for I, so for I in my array, which will actually be this row at a time, and inside that row we'll actually go to for j in I. So inside that row we're accessing these scalars, and we'll print those scalars. So if I run this, as you can see, all the scalars are accessed one by one. Now just to get the scalars, if the dimension increases, it will become a nested for loop. So for n dimension, there should be n many for loops, which is already a hassle to write, and this is actually very slow. So the numpy.nditer method is there to do the same thing. This will actually by default go to the maximum possible depth, and we don't have to use many for loops. So if I run this, the same result has been printed. So some examples of slicing I have shown over here. So first example is this. So by colon we're selecting all the rows, and from there in each row we are accessing the first element, which should be 2, 5, 8 and 11. So if we run this, actually we can see that 2, 5, 8 and 11 has been returned. Next, we are doing the similar thing, but instead of 1, we are giving it a range 0 colon 2. So we should have 0 and then 2. So we will exclude the second index elements. So we should have 1, 2, 4, 5, 7, 8 and 10, 11 returned. So if we run that, 1, 2, 4, 5, 7, 8 and 10, 11 has been returned. Now the last two are self-explanatory. This is exactly how slicing works in Python. And you can also do something like this colon colon minus 1 to reverse it in a specific order. So if we compare over here, 1 2 3 has become 3 to 1, then 4 5 6 has become 6 5 4 and so on. Now we will move to joining of nd arrays, and for that I have created two arrays, and I will use concatenate method to join the array 1 and array 2, and I will save the output in the variable array. Now if we print this, as you can see that after 1, 2, 3, 4, 5, 6 has been concatenated and the result has been returned. Now we can do similar thing for any n dimensional array. So over here I am creating two dimensional arrays. Now I can do concatenate and the output should be as expected. So over here, and I actually have to print this, and if I run this, I have 1, 2, 3, then 7, 8, 9, after that 4, 5, 6, then 10, 11, 12. So both of these array 1 and array 2 are two-dimensional array. We have concatenated both of them and the output is also two-dimensional array. Now if we want to mention a specific axis that we want to join these arrays, then we can use the stack method, and inside the stack method we have to pass in which axis we want to join over. So if I run this, as you can see that 1, 2, 3, then 4, 5, 6 has been returned, and then 7, 8, 9, and after that 10, 11, 12 has been returned. So this is how we can specify a specific axis, then use the joining to create a new array. Now we can do search in NumPy arrays. So I'll have an array with multiple duplicates. So we have 2 over here multiple times, and x I have created using this np.wire method. And inside that I'm passing an expression which will evaluate to either true or false. So I am doing array equals 2. So wherever there is 2 in this array, we want to get all of those indexes. So if I print x, we can see that at the first index, then the third index, and then the sixth index, there are 2. So this x is actually an array which will contain all the occurrences when this condition is true. Similarly, inside the condition we can give something more complex. So over here, all the even occurrences in this array will be printed to x. So as you can see, at first, third, fourth, sixth and seventh indices, we could find any even values. Now one simple thing we can do, if 2 in array, then we can just print like this. So this also in keyword we can use on NumPy arrays. So if I run this, as you can see, 2 was found. Now if I make this 2 to 22 and run this, you can see that this print message has not been procced because 22 is not originally in this array. Now there is a sort function call inside NumPy array. So we can do np.sort, then we can pass in a NumPy array and it will actually return the sorted array. And the sorted array is actually a copy of the original array. So the original array is not sorted in place. Instead, a copy has been created after sorting. So if we run this, the original array is as it is and the sorted array has been sorted in the ascending order. Thank you for watching this video. Thumbs if you liked it. Do share it with your friends and family. And make sure to subscribe for more content and let me know in the comment section below.